time z itself has a value of 1. 1 is less than 3 is true. And therefore, we go to line 5, which is the then branch of the conditional statement. This line on line 5, the right-hand side of the assignment statement is a bracket I. I, once again, has a value of 1. So a bracket I refers to a bracket 1, which has a value of 3. The right-hand side of the assignment is 3. The left-hand side of the assignment statement is z. So that's why z is now updated to 3. So are we okay? So array indexing is interesting because each element inside an array can behave just like any other variables. It can accept a value. It can be on the left-hand side of an assignment statement to be changed. It can also appear on the right-hand side of an assignment statement to become the expression to specify a value. It is really just like any other variables, but it has a funny name. The funny part about its name is it can use an expression to tell the program what you want to access. Okay, it does not have to be a constant. And that is why it is so flexible, because you can, on the same line, you can access a different element. In this program, on the line of line 4, if you look at line 4, in row 7 it's accessing a bracket 0. On row 10 it is accessing a bracket 1. On row 14 is accessing a bracket 2. So the same line in a different iteration of the loop can refer to a different element in the array. And that's why it is so useful, because you can now use a loop to go through all the elements inside the box and perform the same operation to all of them. Are we okay so far with the concept of arrays? Go ahead.
So you could apply this to finding the prime, right?
You can apply this to finding or creating an array of prime numbers to begin with, yes. Okay. Any other questions about the use of an array? No questions so far? Okay, let's go ahead and save this one first and see if the network is back. It's still disconnected. It's not getting anything. Just let me double check and see what's happening with the network. The link itself is down, so that means it is not a local problem. Either the switch or the router is out, so that's why there's no network access from this computer to the outside. It's okay, don't worry, I can teach the class without network access.
This network's been down quite a lot lately.
Yeah.
Has it?
Yeah. I think last weekend I had an outage and a couple weekends before.
This one is not a district issue. This one can be very local. It can be just the switch that this computer connects to is broken. I mean, it can be just as simple as that. Or someone cut the cable, disconnected the cable on the other side, on the other end. It could be one of those things. It always happens on Fridays, because no administrator works on Friday. So then when the network is down, nobody notices. All right, let's go ahead and write some more algorithms using arrays. Let's do one little test case and see if you guys understand what this one will do. I'm not even going to trace it, okay? So I'm just going to say the algorithm starts with a bunch of initializations, okay? A bracket 0 gets 2, A bracket 1 gets 0, A bracket 2 gets 3, and A bracket 3 gets 1, okay? Bunch of initializations, not a problem. All the arrays are completely spelled out, should not be a problem. So what I want to do is to evaluate what is the value of this expression. I think I got 1, 2, 3, 4 levels. Okay. What exactly are we talking about here? It looks kind of funky, huh? Well, can we do it? Can we do something like that? Is there a restriction saying that you cannot have indexing within something that has indexing? There's no rule against it. The only rule is whatever is inside the square brackets has to be an integer value, and it should be from 0 up to bar a bar minus 1 in this case for it to be a valid index. But no one says that you cannot have an expression that involves indexing inside the indexing operator. How do you deal with something like this? What is the first step of evaluating this? The innermost first. Very good. Just like with any type of situation where you have parentheses, you start from the innermost part of the parentheses, in this case, squared brackets. So in this case, what is the innermost part? That would be the innermost part, right? A bracket 1 is the innermost part. What is A bracket 1 according to the initialization? Okay, this one evaluates to 0. And now, what do we do with this? A bracket 0 has a value of 2. Very good. And now what is A bracket 2?
3.
Has a value of 3. And what is the value of A bracket 3?
1.
We're back to 1. Okay? Now, of course, the next question is, what is the practical application of something like this? At this point, we don't have a practical application yet, but at a later point, okay, when we get to records, we can actually create a linked list or a tree structure using only arrays and records. We don't need pointers because once we have array indexing, we can use that for the purpose of creating linked lists and other data structures. Okay, so at this point, we don't have a particular use of it, but later on we will. Do you guys have a question? Yep. Okay. All right. Let's try another algorithm. Okay, remember, it is good to have an array of prime numbers because, with an array of prime numbers, we can optimize the factorization type of program so that we don't have to test composite numbers like 4, 6, 8, 9, and so on. So let's go ahead and see if we can create an algorithm that will initialize an array so the array only has prime numbers. Okay? And we'll do it using the text editor first, and then we can transfer it. This one will take a long time to trace, so I'm not even sure that we want to trace it when we're done with it. Okay? So we want to write an algorithm to find prime numbers and fill an array with prime numbers. Okay. Do you think this one involves a loop? Are we doing something again and again? Okay, sounds like we are doing something again and again. So we'll say revision 1, loop, and loop. Do we want this to be an infinite loop? Nope. So we want to exit when something happens. Very good.
When we hit a certain prime number.
When the entire array is filled up with prime numbers. How about that?
Yeah.
Okay. When the array is filled with prime numbers. Now that is important already because it is telling me that this is a loop. It is also telling me when I'm supposed to get out.
Can you increase the size of the array on the fly if you need to?
It depends on the programming language. It's a good thing and a bad thing at the same time. And I will show you why it is a very bad thing later on, when we talk about short-circuited evaluation. May not be today, maybe next time, maybe next Friday. Okay. So now, I really don't want to say the array. Which array are we talking about? So we want to give it a name. Okay. So in revision 2, we'll say assume array A is the array to be filled with prime numbers. We will also assume I is the indexing variable that tells us which element in the array is getting a prime number. Okay. In that case, is there an easier way to say when we're supposed to get out? Assuming I starts from 0 and works its way up. When it's bar A bar minus 1. But that would be the last element. That would be the last iteration. So when I is more than bar A bar minus 1, then we should get out. Okay. So we can say when I is, sorry? Yeah, when it's greater than or equal to bar A bar. Okay, that's good. Yeah. Okay. Very good. We call this another revision because all we have done is to introduce, some variable names and to make our expression look more like pseudocode. Revision 3. What do you think we are doing per iteration in this case? Okay, we need to increment something. So we basically want to increment I per iteration. Because once we fill up one element with a prime number, we want to move on to the next element and say, okay, in the next iteration, we want this other element to get a prime number. Very good. But before we add 1 to I, what are we going to do with A bracket I? How about we just say A bracket I gets a prime number? Okay, we don't know how to do it yet, but this is what we want to do. And better yet, we can say a new prime number because we don't want to initialize the entire array with 2's, right? Because 2 is a prime number, we can fill up the entire array with 2's and call it a day. That's not very helpful. So we want a new prime number.
Don't you want to initialize I at the same time?
Yeah, we'll deal with the initializations a little bit later. Okay.
That's a sequential prime number too, right? Or
Yep, we want sequential. Okay, so new sequential, the one next to it. Okay. All right, we call it revision 3. In revision 4, we want to kind of focus on what are we going to do? I mean, to find a new prime number. What do I mean by a new and sequential prime number? Let's be more clear about that. Okay, what can I say about this? So it is more clear. Can I say something like this? Can I say that A bracket I will get the prime number next to A bracket I minus 1? Now, what is A bracket I minus 1 here? The previous, okay? The previous item, the item that is previous to A bracket I. It is important to see that the minus 1 is inside the square bracket and not outside the square brackets. I am not subtracting 1 from A bracket I am referring to the element that is before A bracket I. Okay? So if A bracket I minus 1 was 3, then I want 5 into A bracket I. Is that okay? Okay. All right. So we'll just call this another revision. So every single step, we're just making it a little bit more clear as to what we are trying to do and also how to do it. We're up to revision 5. How can I do something like that? A bracket I is going to be the prime number that is greater than A bracket I minus 1, or the next available prime number. How am I going to do that? Any ideas? Any suggestions? How about we say this? How about we start with A bracket I minus 1, find the next prime number, put it in A bracket I. Wouldn't that be a little bit more clear?